Bismillahirrahmanirrahim. In this video, we'll briefly discuss about the solar panels, various types of solar panels that are available, and we'll discuss which one should be using in the present day scenario. So to begin with, we know that there were two types. One is called the monocrystalline and the other is called the polycrystalline. Monocrystalline is black in color, and the polycrystalline is bluish in color. They have slight difference in the performance, and especially for hot climate like Pakistan, the monocrystalline is preferred because it has a slightly less degradation. Now you can see the polycrystalline degrades to 0.43% per degree centigrade, whereas the monocrystalline decreases to 0.40% per degree centigrade. So this means that if you have a 300-watt solar panel and whose panel temperature is 55 degrees centigrade, then this 300-watt panel will be acting as or supplying 261.3 watt if it is a polycrystalline, and if it is a monocrystalline, that will be supplying 264 watt. We will primarily discuss monocrystalline because this is the trend nowadays. Now, a little bit about efficiency. What is solar efficiency? The efficiency means that the amount of electricity produced by the panel. So if there's a panel, sunlight is falling, and how much electric current this solar is producing, that will give its efficiency. And if you see the trend chart of the efficiency from early days where it was 16.6 or less even, it is gradually increasing as the technology is progressing. And nowadays we are somewhere here in this range, and this is more of a laboratory experimentation that are going on. And what all this means that if we had bought a solar cell in 2010, and if it was given 10 amperes, the same size solar cell now in 2022 will give us about 15 amperes of current. Now there are various types: standard, PERC, half-cut, PERC half-cut, bifacial, and bifacial PERC half-cut. So we'll discuss them briefly one by one. Now the standard solar panel is basically, this is the solar cell arranged, and then we have a glass on it, and we have an aluminum rear body, and this is mounted on the or secured with the help of a frame. So this was the early days solar panel. Then somebody thought of, okay, and how is the light produces electricity? So the light enters from here and it touches the solar cells, and the solar cells produce electricity, and the remaining light will just go or pass through this and go at the bottom sheet. So this is how the standard solar cell works. Okay. Now somebody thought of modifying this, that is dividing the cells into two parts. So when cell becomes half and half, that means they are divided into two parts and arranged in parallel. The current in any one of the cell is half of what it used to be for the total current. So half here and half here. And because the current is reduced in the half cell, the losses due to the current will now be reduced. And so there will be an increase in efficiency. Now, if you look at this diagram, same frame here, we have the glass, and then we have encapsulant, so something like this on both sides of the panel so as to prevent humidity penetrating inside. And the solar cell, now in this case, the cell will be cut into two, so that is why it is called half cut. and the back sheet remains same as it is with the aluminum sheet. How much is the improvement? About 2 to 4% more power because of this change in the design. Okay, now this is one great advantage, that when the half cut actually is arranged like this is half of the panel and this is the other half of the panel. Now, if there is a shadow, then what will be the performance? Now, if it was a full panel, full cell, then any shadow will result into zero power output. But in case of a half, if the half portion is even covered by shadow, then the remaining half will produce power. And so we can expect about 50% power output even in the shadows. The next panel that was invented is called the passive emitter and real cell technology, or PERC cell technology. So what they did here is that this glass is now kind of a mirror. So what happens when the light falls from here, touches the solar cell, produces electric energy, the remaining light then goes down into the mirror surface or mirror-like surface, and the light is again reflected back. So when reflected back, touches the solar cell again and produces some more electricity. So something like this, passing through the solar cell one time, going down, reflecting and touching the solar cell second time, so producing some more energy. So this is called the PERC cell, PERC. And in this case, there is about 6% more power than the standard cell. Then somebody thought of combining both half-cut and PERC cell. So the mirror glass is here, and the cells were divided into two parts. So the advantage of both half-cut and PERC, and this has become the more efficient cell. Higher module conversion efficiency, now up to 20.38 or even more. The Neosun company claims it to be 21.5%. And this is one of the commonly used solar cells nowadays. Then came another idea to have a bifacial solar cell. Bifacial means two-phase. And the technology here is that this is the PERC cell. If you remember, light was reflected from here. But in this case, what changes they have done is that they have removed this reflective surfaces. And let's see here. So the reflective glass has been replaced with a normal glass. So what will happen? The light will now go all the way down. And now this aluminum surface has also been removed. So it is a normal glass actually. So the light will now go and strike the ground. And from ground it will reflect back. So look here. This is glass at the bottom. And the reflected light from the ground is coming back again and producing more electricity in the panel. Now, if you look at the views, this is the normal solar cell, front view, and the back we have the aluminum sheet. But in case of a bifacial solar, the front we have panel and back side also is exposed to the panel. So light reflecting will touch this and produce more energy. So the bifacial is producing about 30% more power in this case from the monofacial. Now you can see at time of the day, at the midday, it is producing about 30% more. Now what is requirement for this is that the surface below has to be kind of a polished surface. So light falling on this, going down, and then reflecting back will produce the double, almost double the energy. So one is that the surface should be polished, and the other is that the panels should be tilted with some more angle, so the light falling from here goes down and reflects back, or even the surrounding light also touches the panel from the rear side to produce more energy. Okay, there is a price difference of about 3 rupees between the perk cell or the mono perk cell and the bifacial cell, but I guess it is worth the amount of energy that they add. Now let's see two examples. This house has 20 kilowatt system, and they have used Jinko 540 watt mono perk half cut solar cells. So this is one of the solar cells which are being used now, and its efficiency is about 21.35. And the 540 watt solar actually will be giving about 402 watts in the normal operating conditions, and in the extreme even this will go down further. Anyway, the point that I want to make here is that look, there is a lot of light in the behind the or underneath the solar cells, and if this was instead of a perk cell, if this was a bifacial cell, then definitely there would have been more reflection from here. So this is my idea that bifacial would do a better job here. On the contrary, look here, this gentleman is using the bifacial cell, and this is the wall of the house. Now there is no place from where the light would reflect back. So this is the place where they should have used perk solar cell or perk half cut cell instead of the bifacial mono perk panel cell. So I hope this has given you some kind of an idea as to which type of a solar cell we should select. And as we mentioned that for the bifacial, we got to have a polished source from where the light could reflect. Now, a Blue Stream Energy Solution Company has carried out a research, and their research shows that the overall production of the bifacial solar cells are about 5.5% more, and this is considered to be the future. So for like 7 months, they have found out that the production is, let's say, 1 million 0.71, whereas the monofacial is 1.015. That means the difference between the two is 56,000. So the bifacial has 56,000 more production. So if you like this video, please let me know through your comments.